ISE-47. So today I'll be explaining you the sixth program, that is knapsack program, using a greedy method as well as a dynamic method. So here we are going to see the explanation of the program. Okay.
Yeah, good morning students. So welcome to the sixth program, knapsack DP. Okay, so here we have import java.util.scanner, which is similar to that of your header file. Okay, because all the definitions of the all the methods, okay, will be defined under java.util.scanner, or we'll just say java.util.star. Okay, so here it's a knapsack. Okay, with you're going to solve the knapsack problem using a dynamic programming technique. Okay, so what do you mean by a dynamic programming technique? Okay, so here, maximum in terms of dynamic programming, we are going to consider it as a in a matrix form. Okay, no matter it's a flights or Warshall, so we are going to consider it as in a matrix form. Okay, so in terms of a knapsack DP, here we are going to specify the maximum size of the knapsack. We are going to consider the weight, profit, the number of objects, the capacity of the knapsack, okay, and the DP solution process table, that is a table like the matrix which we are going to keep it, and then here it's a keep is a matrix to keep the objects in a optimal solution. So as we know that here the execution starts with main, we are going to give the value for W, P and V, okay, which is weight, profit and value. Okay, the value, that is a DP solution process table over here. Okay, next is a keep matrix. So end optimal solution, we are going to declare an optimal solution of type end. Then here you are going to read objects. So once you call this read object, okay, so it comes to this read object function. Okay, so using this scanner is an object, new scanner system.in. Okay, so using the system.out.println. Okay, so you're going to say knapsack dynamic programming, you're going to enter the capacity. To M you're going to enter the capacity of the knapsack, to N you're going to enter the number of objects and enter the weights for the number of objects which you're going to specify, and also you're going to enter the profit. Okay, you're going to enter the profit. Okay, and after that here the row value and the column value with respect to 0, okay, like say for an example 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, you're going to make it as a 0. Next 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, you're going to make it as a 0, and then for obtaining an optimal solution you're going to call the knapsack. So since it's a dynamic programming knapsack, okay, so here we have an R to keep track of a remaining capacity of the knapsack. Okay, here we will be using a 2 for loop, since it's an one for the row and another one is for the column. Since the first row itself is 0 and the first column is 0, so we are going to make I equals 1. Okay, so we are going to check whether the particular weight is less than or equal to J. Okay, that is the value, and we are going to find out whether the profit of that particular first item plus the remaining value of I minus 1 item plus J minus W of I, if it is greater than that of V of I minus 1 of J, so in that case the value will be obtained as P of I plus I minus 1 J minus WI. Then we are going to keep that particular element in the matrix. Else we are going to say V of I minus J is V of I minus 1 of J. So keep of Ij, you are not going to consider that. Okay, next finding the objects in terms of a knapsack. Okay, so here the remaining capacity will be given to R, which are the various items. So here you are going to go from N, that is the number of item greater than 0, and I minus minus. Okay, and then here you are going to keep of IR equal to 1. So keep of I and R, if it's equal to 1, then you are going to consider that, and then the remaining capacity of the knapsack is calculated by R equal R minus W of I. And then after executing after all the rows and columns, so you're going to get at V, you're going to get the result at V of N of M. Suppose your number of objects is 4, number of object is 4, okay, and the capacity of the knapsack is 5, so you are going to get the result at V of 4 of 5. So you have to keep that in mind. Okay, now let's execute the program. That's a knapsack using a dynamic programming. Okay, what's the maximum capacity of the knapsack? I'll just say 5. Okay, the number of objects is 4. Okay, 1 2 2 1. Okay, enter the profits 10 12 14 15. Okay, so the optimal solution what we got is 41. So the items that will be included in the knapsack is 4 3 and 2, because the size of the knapsack capacity is